Imagine the heart of our galaxy. For decades, we thought a monster lurked there, supermassive black hole. But what if we've been wrong all along? Tonight, we dive into strange theories, bizarre evidence, and the possibility that the universe is trolling us. Chapter 1. The galactic monster we thought we knew. Imagine standing on Earth, looking up at the night sky. To the naked eye, the Milky Way appears as a faint, glowing band across the darkness. But hidden deep in that band, 26,000 light-years away, sits something that has fascinated, puzzled, and terrified astronomers for decades. Sagittarius A, or SGRA for short. For most of modern astronomy, we believed this object is a supermassive black hole, a monster, millions of times heavier than our Sun. It's supposed to be the anchor of our galaxy, the cosmic heavyweight that keeps the Milky Way in order. That's the story we all learned. But as with every good mystery, there's a catch. The closer we look, the stranger it gets. The idea of the galactic heart. Let's rewind a little. The concept of black holes has been around for a long time. They were first predicted by Einstein's general relativity in the early 20th century, though even Einstein himself wasn't thrilled with the idea. A black hole is basically gravity gone rogue, matter so dense that nothing, not even light, can escape. Imagine compressing the mass of Earth into the size of a marble. That's still nothing compared to Sagittarius A*. SGRA** is estimated to have the mass of about 4 million suns. If you placed it where our Sun is now, its event horizon, the invisible boundary where nothing can escape, would stretch farther than Mercury's orbit. That's the kind of power we're talking about. And yet, from Earth, we can't actually see it. A black hole gives off no light. Instead, astronomers detect its presence through the chaos around it. Stars whipping around invisible orbits, gas clouds twisting in gravitational spirals, radiation flaring from heated matter as it falls toward oblivion. The stars that betrayed the monster. The most famous evidence for SGRA** came from a group of stars nicknamed the S. Over decades of observations, astronomers noticed these stars orbiting an unseen object at incredible speeds. One star, known as S2, completes its orbit in just 16 years. For comparison, Pluto takes 248 years to go around the Sun. To make a star move that fast, something incredibly massive had to be there, crammed into a tiny space. It wasn't glowing like a cluster of stars. It wasn't visible like a giant ball of gas. The only explanation that fit the math was a supermassive black hole. Astronomers cheered. This was the smoking gun. Nobel Prizes were awarded in 2024, proving beyond doubt that our galaxy has a black hole at its center. Case closed. Right, the personality of a black hole. Not exactly. Here's the thing. Black holes are supposed to act in certain ways. They pull in matter. They release bursts of X-rays and radiation when gas spirals into them. They create chaos in their neighborhoods. But Sagittarius A** is oddly quiet. Compared to other galaxies, our central black hole is like a party host who forgot to invite anyone. Instead of shining with the furious energy we see in other galactic cores, it mostly sits there, dim and reserved. Astronomers expected more fireworks from something this massive. That's the first hint that something might be off. A little humor with the darkness. Think of it like this. Sagittarius A** is supposed to be the ultimate cosmic vacuum cleaner, but instead of sucking in everything nearby, it sometimes behaves like a lazy Roomba that only cleans when it feels like it. It has the mass, it has the gravity, but its activity is strangely inconsistent. And that inconsistency is what makes astronomers nervous, because in science, when something doesn't fit the rulebook, it usually means the rulebook is missing a chapter. A monster, or a mirage. The name black hole itself sounds terrifying. Hollywood has painted them as unstoppable space whirlpools that could rip apart anything in their path. And yes, they're powerful, but Sagittarius A** isn't swallowing our galaxy whole. In fact, from Earth, we're in no danger. Still, the mystery is compelling. If this is truly a supermassive black hole, it's an unusually quiet one. If it's not a black hole, then what exactly is it? That's where the story gets interesting. Setting the stage for doubt over the past 2 decades, better telescopes and new data have started poking holes in the neat black hole narrative. Scientists have spotted things they didn't expect. Gas clouds passing close and surviving, weaker radiation than predicted, and strange variability in its emissions. Each new piece of evidence forces astronomers to ask, are we sure we know what we're looking at? Here's a playful analogy. Imagine ordering a cheeseburger. You expect bread, meat, cheese, but when it arrives, the bun is there, the cheese is there, but the meat looks suspiciously like tofu. Is it still a burger, or have you been tricked into eating something else? That's Sagittarius A asterisk call. The signs say black hole, but the taste test is confusing. Why it matters at this point, you might wonder. Why should we care? After all, SGRA asterisk is unimaginably far away. It's not pulling Earth into oblivion anytime soon. The answer is simple. The center of our galaxy tells us about the universe itself. If we misunderstand what's happening there, it means our theories about gravity, dark matter, and cosmic evolution could be incomplete. It's like thinking you understand how cars work, only to realize the engine under the hood is something completely different. For scientists, that's both terrifying and thrilling. The cliffhanger, so here we are. We thought we had solved the mystery of the Milky Way's heart. We thought we'd found the monster lurking in the dark. But the closer we look, the more the monster looks like something else entirely. Is Sagittarius A asterisk really the black hole we think it is? Or is it something stranger, something we haven't even imagined yet? That's where Chapter 2 comes in, the part where the evidence begins to crack and the mystery deepens. Chapter 2. The evidence starts to crack in Chapter 1. We painted the picture of Sagittarius A asterisk as the heart of our galaxy, a cosmic heavyweight, most likely a black hole. That was the official story, the one that won Nobel Prizes and filled astronomy textbooks. But here's where things get messy. The universe doesn't like neat answers. Every time scientists thought they had Sagittarius A asterisk figured out, the evidence began to crack. Tiny details, strange behaviors, and surprising survival stories started to pile up. And when it comes to space, small cracks can hide enormous mysteries. The gas cloud that refused to die. Let's start with one of the strangest events, the gas cloud known as G2, discovered in the early 2000s. G2 was on a trajectory that would bring it dangerously close to Sagittarius A asterisk. Astronomers were thrilled. This was supposed to be a front-row seat to cosmic destruction. The prediction was clear. As the cloud approached, the black hole would rip it apart. We'd watch fireworks as gas spiraled in, heated up, and blasted radiation across space. Telescopes worldwide were pointed at the center of the Milky Way, ready for the show. And then, nothing happened. G2 passed near Sagittarius A asterisk, brushed up against the supposed black hole's gravity, and emerged almost intact. Sure, it stretched a bit, but it didn't vanish into fiery chaos. The doom pass turned into a slightly rough roller coaster ride. It's like throwing a marshmallow into a bonfire and finding it come out lightly toasted. That's not what the textbooks predicted. If Sagittarius A asterisk is truly a supermassive black hole, why didn't it tear G2 apart? Why didn't we see the dramatic flares everyone expected? Stars that blink but don't behave. The gas cloud wasn't the only puzzle. Astronomers also noticed irregular dips in star brightness near the galactic center. Normally, when a star dims, it's often because a planet is crossing in front of it to transit. We've used this method to find thousands of exoplanets, but these dips didn't fit the pattern. The brightness dropped too much, sometimes as much as 20%, and then bounced back. Planets couldn't explain it. Dust clouds didn't quite match either. Something else was at play. This kind of behavior raises uncomfortable questions. If nearby stars are flickering in strange ways, maybe the environment around Sagittarius A asterisk is more complex than we realize. Or maybe the object itself is doing something weird, something a normal black hole shouldn't do. The case of the missing radiation, another crack in the story is radiation, or, more accurately, the lack of it. Black holes feeding on matter are messy eaters. They create powerful X-ray flares as gas and dust heat up while spiraling inward. In other galaxies, supermassive black holes shine like cosmic lighthouses, blasting radiation so bright we can detect them billions of light-years away. Sagittarius A*, by comparison, is strangely quiet. It does emit some radio waves and occasional faint X-rays, but nothing close to the intensity we'd expect from something of its size. One scientist compared it to finding a tiger that purrs like a kitten. Sure, it's still a big cat, but why is it so unusually calm? Is Sagittarius A** starving? Is it dormant? Or is it not what we think it is at all? The blurry shadow that doesn't match. The Event Horizon Telescope (EHT) made history in 2019 by capturing the first ever image of a black hole's shadow, the iconic orange ring of light around the one in galaxy M87. Naturally, astronomers turned the EHT toward Sagittarius A** to repeat the feat. In 2022, we finally got an image. It was fuzzy, messy, and unstable. Unlike the clean ring seen in M87, the shadow of Sagittarius A* seemed blurrier and less defined. It didn't quite match predictions. Now, to be fair, imaging SGRA* is much harder, because it's smaller and changes more quickly. The light we see flickers on timescales of minutes instead of days, but still, the result added fuel to the fire. What if our assumptions about this object are off? A monster with identity issues put all of these anomalies together, and the story starts to wobble. A gas cloud that refuses to die. Stars flickering in ways we can't explain. Radiation levels that don't add up. A shadow that looks blurrier than expected. Each one might be dismissed on its own. Maybe G2 was denser than expected. Maybe the star dips are just dust behaving strangely. Maybe Sagittarius A* is just in a quiet phase, but when you add them together, the picture becomes harder to ignore. It's like hearing excuses from a friend. 1 missed call is fine, 2 missed calls is still okay. But by the 5th time they cancel plans, you start to wonder if something else is going on. Humor in the confusion. At this point, scientists are scratching their heads. Sagittarius A** acts like a black hole. Most of the time, but every now and then, it pulls a trick that doesn't fit the script. It's as if the universe ordered a black hole costume online, but what arrived was a knockoff version. Looks convincing from a distance, but up close, the seams don't line up. And honestly, that's both frustrating and hilarious. Astronomers spend billions of dollars, build the world's most advanced telescopes, and what do they get? An object that plays cosmic peekaboo. Why it's a big deal? This isn't just academic nitpicking. The anomalies matter because they hint that our understanding of gravity and galactic centers may be incomplete. If Sagittarius A** doesn't behave like other black holes, maybe the rules we've written aren't the final draft. It's like finding a grammar mistake in a dictionary. Sure, most of the words are fine, but if the official rulebook is wrong even once, it shakes your confidence in the whole thing. And that's the exciting part. These cracks don't just create problems, they create possibilities. They open the door to new theories, new physics, and maybe even entirely new categories of cosmic objects. The transition to bigger questions. So where does that leave us? We have an object that quacks like a black hole, waddles like a black hole, but occasionally refuses to act like one. The evidence doesn't fully add up, which brings us to the next stage of the mystery. If it's not a black hole, then what cosmic imposter is sitting at the center of everything? That's the question we'll explore in Chapter 3, where the theories get stranger, the science gets weirder, and the possibilities might just bend reality itself. Chapter 3, Wild Alternatives and Strange Theories. So far, we've been walking down the well-paved road of black hole theory. The textbooks say Sagittarius A* is a black hole, case closed. But what if the textbooks are wrong? What if the universe has a sense of humor and we've even been trying to solve the wrong puzzle all along? Tonight, let's wander off the main road and peek into the side alleys of cosmic speculation. These are the theories that don't get the spotlight in school lectures, but they ignite heated debates at astronomy conferences, late-night Reddit threads, and maybe even in the minds of alien astrophysicists laughing at us from far away. 1. The Boson Star hypothesis. Imagine, for a moment, that instead of a black hole crushing everything into an infinite point, the heart of our galaxy is a star, but not a star like the sun. No glowing plasma, no nuclear fusion, no warm fuzzy sunlight. Instead, this would be a boson star. Bosons are exotic particles different from the electrons, protons, and neutrons that make up the stuff we're used to. Think of them as the universe's weirder Lego blocks. Normally, bosons don't like to hang out in giant clumps, but under certain conditions, they might come together in a massive, ghostly ball of matter. If Sagittarius A * were a boson star, it could mimic many of the same effects as a black hole. Strong gravity, objects orbiting it at wild speeds, light bending around it. But unlike a black hole, it wouldn't have a point of no return, no event horizons swallowing everything forever. Instead, you'd have this strange, invisible sphere made of particles so exotic that we don't even know if they really exist. Here's the kicker. If boson stars exist, they could solve more than just this mystery. They might also be tied to dark matter, the mysterious substance that makes up most of the universe's mass. But doesn't shine or reflect light. A boson star at the center of our galaxy would be like killing two cosmic birds with one particle. But then again, no one has ever seen a boson star. It's like inventing a new type of dessert by imagining a flavor you've never tasted. Sweet, maybe. Delicious, who knows? 2. The wormhole possibility. Now, let's dial up the sci-fi dial. What if Sagittarius A* isn't a star or even a thing at all? What if it's a doorway? Enter the wormhole theory. A wormhole is basically a cosmic subway entrance. You step in on one side of the universe and pop out on the other side faster than light could ever travel. They've been a favorite of science fiction writers for decades. Einstein himself played with the math that made them possible. So imagine, what if the shadow astronomers think as a black hole is actually the opening of a wormhole? That would explain some of the oddities we've seen. The weaker than expected radiation. Maybe because matter isn't being shredded, it's being transported. The fuzzier shadow. Maybe it's turbulence at the entrance, like looking into a windy tunnel. Of course, there's a giant problem with this idea. Stability. The equations say wormholes collapse quickly unless you stabilize them with exotic matter. And we don't exactly have exotic matter lying around, unless Sagittarius A* is exotic matter. If that's the case, then our galaxy's center is basically the universe's grand central station. Somewhere out there, aliens could be swiping their wormhole transit passes, hopping from galaxy to galaxy, while we're just standing here wondering why our telescopes can't make sense of it. And hey, if Earth's GPS satellites ever start rerouting us through another dimension, maybe we'll finally know we've found the entrance. 3. The fuzzy dark matter core. Now, let's get even stranger. Some scientists have suggested that Sagittarius A* could be a big ball of dark matter, not the regular, invisible filler that astronomers think surrounds galaxies, but a condensed, fuzzy lump of it right in the middle. Dark matter is already weird. We can't see it, we can't touch it, but it is definitely there because galaxies spin in ways that only make sense if something invisible is adding mass. But what if, in some places, dark matter isn't spread out like mist? What if it clumps together like cosmic cotton candy? This fuzzy dark matter theory suggests that Sagittarius A* could be a stable blob of dark matter particles, dense enough to pull stars into orbit but not dense enough to collapse into a black hole. Picture it, at the heart of our galaxy. Instead of a terrifying black hole sucking up everything, we've got a giant ball of invisible fluff. the most powerful cotton ball in the universe. This would explain why Sagittarius A** doesn't behave like a normal black hole. It's less violent, less hungry, less dramatic. In other words, it's the introvert of cosmic centers, quietly sitting there while the rest of the galaxy spins around it. 4. When science sounds like sci-fi, here's where the fun really kicks in. Whether it's boson, stars, wormholes, or fuzzy dark matter, these theories all highlight the same thing. Our cosmic detective story is still unsolved. The truth is, the universe doesn't care about our neat categories. It doesn't fit into our PowerPoint slides or clean equations. Sometimes it feels like the universe is writing its own science fiction fanfiction using real physics, but in ways we haven't figured out yet. Or as one scientist once joked, basically, the universe is either writing sci-fi fanfiction or we just haven't read the manual yet. And isn't that the beauty of it? We don't know. We get to keep wondering, keep questioning, keep imagining possibilities that sound too wild to be true until one day they turn out to be real. 5. The engagement moment now. Here's where I want to pull you into the conversation. If you had to bet on it, what do you think is really sitting at the center of our galaxy? The classic black hole, crushing space and time. A wormhole, an intergalactic subway tunnel waiting for its first passengers. A Boson Star, made of ghostly particles we haven't even confirmed. Or maybe my personal favorite, a giant cosmic jelly bouquet. Not scientifically accurate, but at least it explains why space is so sweetly mysterious. Drop your guess in the comments. I want to see who's team black hole, who's team wormhole, and who's team cosmic jelly bean. Wrapping up the chapter, theories like these remind us that science is not about having all the answers, it's about knowing which questions are worth asking. Sagittarius A** could be a black hole, sure, but it could also be something much stranger, something that forces us to rewrite the rules. And as long as it keeps puzzling us, we get to play this game of cosmic what if, because maybe, just maybe, the universe is stranger than we're even capable of imagining. Chapter 4. What it would mean for us up until now. We've been circling around the question, what exactly is Sagittarius A? Black hole, wormhole, boson, star, fuzzy dark matter. But let's pause and ask a different question. Why should we care? After all, the center of the galaxy is 26,000 light-years away. Whatever is sitting there isn't going to swallow Earth tomorrow, but the consequences of what it is could ripple across science, technology, and even the way we see ourselves in the universe. So let's break down what these wild alternatives would actually mean for physics, for daily life, and maybe for your Wi-Fi connection. 1. If it's not a black hole, physics gets a rewrite. Albert Einstein's theory of general relativity has been one of the crown jewels of physics for over a century. It predicted black holes before we even had a name for them, and so far, relativity has passed every test thrown at it: gravitational waves, time dilation, light bending around stars. But if Sagittarius A** turns out not to be a black hole, it's like discovering your calculator has been giving you the wrong answers for years. Not completely wrong but off, just enough to make you question the foundations. If it's a Boson Star, that means new fundamental particles exist beyond what we've ever detected. Physicists would have to expand the standard model of particle physics, the same way cartographers once had to add new continents to old maps. If it's a wormhole, then space-time itself is far more flexible than we thought. Suddenly, faster than light travel isn't just Cepheid's geometry. If it's fuzzy dark matter, then dark matter isn't just a background ingredient, it can shape galaxies in ways we never imagined. In each case, the textbooks would need new chapters. The equations written on chalkboards across the world would get messy revisions, and every physicist secretly hopes for this, because rewriting the rules means new discoveries, new Nobel Prizes, and maybe even new technologies. 2. Cosmic what-ifs meet daily life. Alright, let's bring this back down to Earth. It's fun to imagine distant galaxies, but what would this mean for us humans, scrolling YouTube on a Tuesday night? If Sagittarius A asterisk is a wormhole, picture your GPS one day glitching in 300 feet, turn left, and arrive in the Andromeda galaxy. Not great for your morning commute, but incredible for intergalactic tourism. If it's dark matter at the core, maybe that explains why your Wi-Fi drops every night. You're not losing connection, it's just dark matter absorbing your signal. Okay, not really, but admit it. You'd blame dark matter if you could. If it's a Boson Star, maybe one day we'll harness bosons for clean infinite energy. Imagine charging your phone in 2 seconds thanks to galactic particle tech. Suddenly, running out of battery at 2% won't be a thing anymore. The truth is, these scenarios are exaggerations, but they're fun exaggerations. Because when cosmic mysteries touch everyday life, they stop being abstract science and become stories we can laugh about at dinner tables. 3. Grounding it in reality now. Let's switch gears. Because even though we're joking about wormhole GPS and cosmic Wi-Fi thieves, the reality is just as fascinating. Right now, some of the most advanced observatories on Earth and in space are trying to answer this riddle. The Event Horizon Telescope (ET) already gave us the first picture of a black hole's shadow. Its next upgrades aim to sharpen those fuzzy images of Sagittarius A asterisk. The James Webb Space Telescope (JWST) is peering into the dust clouds near the galactic core, capturing light in wavelengths we couldn't see before. And the upcoming extremely large telescope ELT, with a mirror nearly 40 meters wide, will zoom in on stars orbiting Sagittarius A asterisk with breathtaking precision. Each of these instruments is like another magnifying glass pointed at the mystery. They're giving us data that could confirm, challenge, or completely overturn the black hole story. Think about it. Within our lifetime, we might learn that the very thing anchoring our galaxy isn't what we thought. That's not just science, it's history unfolding. For why it matters to us as humans beyond equations and telescopes, there's something deeper at play here. Humans are storytellers. We've always looked at the sky and asked, what's out there? What does it mean for us? If Sagittarius A asterisk is a black hole, then the universe is as dramatic and violent as we imagined. If it's something stranger like a wormhole or dark matter core, then the universe is more playful, more bizarre, maybe even more generous than we dared hope. Either way, the answer shapes our identity. It tells us whether we're living in a universe that follows strict rules, or one that bends those rules in ways that invite imagination. And in a way, that's the real impact. It changes not how we travel or use Wi-Fi, but how we dream. 5. Humor break. Because the universe is weird, before we get too serious, let's throw in a little perspective. If it's a wormhole, maybe NASA's next press release will read, "Good news, we've discovered instant travel across galaxies." Bad news, your Amazon package might now be delayed by a few million light years. If it's a dark matter core, scientists finally confirm why your cat stares at the wall at 3 a.m. It's detecting fluctuations in the galactic dark matter field. And if it's a Boson Star, turns out the galaxy runs on ghost particles, which, coincidentally, is also what my diet feels like every time I forget to buy groceries. Sometimes humor is the best way to deal with the fact that the universe is too strange to process without laughing a little. 6. The cliffhanger. Here's the thing. The more we study Sagittarius A asterisk, the stranger it gets. Instead of closing the book on the mystery, every new observation adds another twist. We thought a gas cloud would be torn apart. It wasn't. We thought the radiation levels would match predictions. They didn't. We thought the shadow would be crisp. It's fuzzier than expected. So maybe it's a black hole. Maybe it's something else entirely. But either way, the story is far from finished. And that S where we leave you hanging tonight with the promise that the universe's weirdest mysteries aren't solved. They're only getting started. Chapter 5. Mystery, Meaning. And moving forward, we've traveled a long way together through this cosmic riddle. From the early hints that something at the center of our galaxy didn't behave quite right, to wild theories about wormholes, boson stars, and cosmic cotton candy made of dark matter. And yet, here we are, still circling the same truth. We don't really know what Sagittarius A asterisk is. Yes, the safest bet, the one most textbooks still make us, that it's a black hole. That's the model that fits most of the data. But even as we say it, we know the story is incomplete. Like a half-finished puzzle, the picture makes sense, until you notice pieces that don't quite line up. So, what do we do with this mystery? We sit with it, we let it stretch our imaginations, and we remind ourselves that the universe is under no obligation to make sense to us on the first try. 1. The beauty of an open door. The phrase black hole has become a stand-in for Sagittarius A asterisk, because it's the closest idea we have. It explains the orbits of stars near the galactic center. It explains the bending of light. It explains the gravity well anchoring the Milky Way. But the unexplained anomalies, the fuzzy shadow, the underfed appetite, the gas clouds that refuse to be shredded, those anomalies leave the door wide open. They whisper, maybe the universe still has surprises waiting. And that's the beauty of science. It doesn't slam the door shut with final answers. It leaves it ajar, so we can peek through, wonder what's beyond, and keep asking questions. 2. What if we don't have the words yet? Here's a thought experiment. What if the core of our galaxy is something so foreign, so outside our current frameworks, that we literally don't have the language to describe it? Imagine explaining Wi-Fi to someone in the year 1500. You could try all day. Invisible waves, data packets, information flying through the air. At best, they'd nod politely. At worst, they'd accuse you of witchcraft. That might be us right now. Standing in the cosmic dark, trying to describe something with the wrong dictionary. We say black hole, wormhole, Boson Star, but maybe Sagittarius A asterisk is none of the above. Maybe it's a category of object we haven't even conceived yet. And isn't that thrilling? To think that the universe might be waiting for us to invent the words that will finally make sense of it. 3. OW, the humbling scale of it all. No matter what Sagittarius A asterisk turns out to be, here's the part that humbles me every time. At the heart of our galaxy, 26,000 light-years away, lies an object so massive it keeps billions of stars, including our sun, dancing in orbit. We're talking about something 4 million times more massive than the sun, sitting quietly at the core, shaping the Milky Way's destiny. And yet, we can't define it. We can't box it up neatly. We point telescopes, build equations, launch observatories, and still the mystery deepens. That's not failure. That's wonder. It reminds us how small we are, but also how bold we become, daring to stare at the center of our galaxy and ask, what are you, really? 4. Playful wonder. Bringing it home, of course. We can't end without a little playful speculation, because if the universe insists on being weird, we may as well enjoy it. If Sagittarius A asterisk is a wormhole, then maybe our galaxy has a secret back door. Who knows? Aliens might already be using it as their shortcut, while we sit here stuck in traffic on the cosmic freeway. If it's a Boson Star, then we're reliving in a galaxy powered by ghost particles, a kind of quantum fuel that might someday revolutionize how we use energy. If it's dark matter, then every time your Wi-Fi cuts out, you can just shrug and say, well, blame the galactic core. And if it is just a black hole, then maybe that's no less fascinating, because black holes are already among the most mysterious, reality-bending objects we know. Sometimes the simplest answer is still the strangest. 5. Why mysteries matter. Let's zoom out for a moment. Why does this mystery matter? Why spend billions on telescopes and decades puzzling over fuzzy images of a faraway shadow? Because mysteries drive us forward. They give us something to chase. Every time we bump into the limits of our knowledge, we're reminded that there's more out there, more to learn, more to dream, more to discover. Sagittarius A asterisk is more than an object. It's a symbol, a reminder that the universe isn't finished surprising us, that even at the center of our own galaxy, our cosmic backyard, there are secrets waiting to be uncovered. And when we push against those mysteries, we grow, not just in knowledge, but in imagination. 6. Humor, close. The neighbor analogy. So where does that leave us? For now, Sagittarius A** remains that mysterious neighbor down the street. Probably harmless, mostly quiet, maybe even friendly. But deep down, you're not entirely sure. Do they have a wormhole hidden in their garage? A stash of dark matter in the basement? Are they hosting cosmic poker nights with Boson Stars? Until we know for certain, we'll keep peeking through the blinds our telescopes, trying to catch a glimpse of what's really going on over there. 7. Moving forward together. The truth is, the more we learn about the universe, the stranger it gets. That's not discouraging, it's exhilarating. Each anomaly, each unanswered question, is an invitation to look deeper, dream bigger, and laugh a little along the way. And you get to be part of that journey. Every like, every comment, every late-night conversation sparked by videos like this adds fuel to the collective wonder that pushes us forward. So if this mystery has stirred your curiosity, hit the like button, subscribe for more stories like this, and share your wildest theory in the comments. Team Black Hole, Team Wormhole, Team Dark Matter Wi-Fi, or Team something so strange we don't even have the words yet. Whatever you choose, the conversation is part of the adventure. As we close this chapter, remember, mysteries aren't gaps in our knowledge, they're bridges to the future. And Sagittarius A** whether black hole, wormhole, or cosmic jellybean will keep pulling us forward, just as it pulls our entire galaxy around it. Because at the end of the day, the center of the galaxy isn't just out there in the sky, it's also in here, in the center of our curiosity. And that, perhaps, is the greatest force in the universe. If this journey through the heart of the galaxy got you thinking, consider leaving a like, maybe subscribe for more mysteries, and drop a comment. What do you think is hiding at the Milky Way's center?